STEM Mass Media.
Here with us today is Abigail Diaz,
Isabel Montano,
and Ptolemy Jury.
Today's top story dives into an interesting chapter in Earth's history. Scientists have found evidence that the Sahara-Arabian Desert was not always dry land as we see today.
A group of researchers led by Max Planck Institute for Chemistry uncovered proof that the region had experienced periods of rainfall over the past 8 million years. These wet periods temporarily altered parts of the Arabian Peninsula, making them suitable environments for the survival of plants and animals.
To determine Arabia's ancient climates, researchers have looked over cave formations known as stalactites and stalagmites. These mineral structures are formed gradually as rainwater seeps through rock layers of calcium carbonate over time. To help us further understand the science behind this, we're joined by Mr. Drury.
Because of limestone caves being climate archives, the chemical composition of calcium carbonate in the speleothems changes with the climate over the cave. By using these deposits and analyzing them, researchers can find past climates with temperature and precipitation patterns at the time the speleothem was formed.
Thank you, Mr. Jury. Now back with us. By studying chemical fingerprints trapped inside those layers, specifically the oxygen and hydrogen isotopes, scientists were able to determine when long periods of rainfall occurred. Using radiometric dating techniques, they were also able to establish the ages of deposits and create a timeline that stretches back around 8 million years.
These results show that the Arabian Peninsula has experienced many humid intervals that lasted thousands of years.
During these periods, monsoon systems reached farther north than they do now. They delivered rainfall that would have supported lakes, vegetation, and wildlife.
But as global temperatures in the northern hemisphere slowly cooled over millions of years, monsoon patterns shifted to the south. The climate change reduced rainfall in Arabia, making the desert conditions we know today. The implication of this research goes far beyond understanding ancient rainfall.
As of now, the Sahara-Arabian Desert acts as a geographic barrier between Africa and Eurasia. But during the wetter climate phases, the barrier would have been less extreme.
Rivers, grasslands, and even fresh water sources may have opened migration routes for moving animals between places.
Some scientists suggest that these greener times could have played a role in movement of early humans. This study also gives valuable insights on how global climate systems respond to temperature shifts. Slow changes in global cooling altered monsoon patterns enough to transform a region's entire environment.
Understanding these changes from the past may help researchers better see how modern climate change could influence rainfall systems and desert expansion in the near future.
What now appears to be endless desert once had cycles of renewal and rainfall.
Thanks to chemical clues that were preserved inside cave formations, scientists have been able to uncover environmental history that reshapes the way we understand migration, climate, and even Earth's long-term evolution. Your cue to never judge a book by its cover.
From yours truly,
STEM Mass Media.
We're your top choice.
Stay curious.